Hello, everyone. I'm going to go ahead and get started. Welcome to our session. Thank you very much for coming. I realize there's free drinks after this, so we're going to try to keep you entertained until then. We'll talk about supercharging your mobile game with YouTube. And I would like to introduce my co-presenter, Corey, from Unity. He is working on Unity implementations with a number of partners. So I wanted to start with this photo that I found on the internet. As you can tell, it was taken a while ago. There's a few really excited mobile gamers. This photo was taken at a gaming convention in Vancouver, Canada. The question that popped into my mind when I saw this is, what would it take to excite and energize your gamers, your players, your customers equally today? Well, if you look at some stats, there was a study done 2 years ago, and 95% of gamers that spend significant time playing games watch user-generated content on YouTube. So these are gaming clips. Actually, the number for trailers is 94%. So more people watch user-generated content than the highly produced gaming trailers. In fact, there's several companies already taking advantage of this trend. So some of these titles that I'll show you will probably be familiar to you. Trial Extreme 3, FIFA 13 has video upload capability, so you can share your gameplay directly from the game. And then the granddaddy of them all, Talking Tom. This is an application that has really taken great advantage of video sharing. So in that app, you can create a video. It's both a nice virtual pet type of app as well as self-expression platform. So this is what we'll talk about today. We will show you how you can take a sample Unity game that we built for this purpose, and then integrate YouTube API in order to share the gameplay with the world. YouTube has 1 billion users, so there's a billion potential customers out there. And then we will show you both the upload and playback capability, how that can be integrated into a Unity game. So really, the only thing you have to do as a game developer is focus on building a great game. That's it. So first, I wanted to show you a little demo of the game that we have built for this purpose. So here's my game, and the objective of this game is to shoot these gas cans as fast as possible. And I am pretty bad at it, as you can tell, but I'm going to try to do my best. One more. Oh, I got 12 points. All right, time is up. So the next step, I just had this wonderful score of 12 points. I would like to watch myself play this game. So here's the replay. Pretty amazing. I rock. So what I do next is, I definitely want to share this gameplay on YouTube. So I'm going to hit the YouTube button and let this processing take place. What this means to you is, imagine you were playing an awesome game, some sort of a Warfare simulation, and with your best friend, and you just blew up his or her Abrams tank. You can share that achievement on YouTube, and then they claim the bragging rights for the rest of the week. Now, I would like to introduce Corey, who will take you through the process of creating games with Unity, and then he will discuss some of the plugging opportunities that exist within the Unity framework. After that, I'll take you through the process of actually integration between YouTube APIs and Unity. So over to you, Corey.
Thank you. Hello, everyone. My name is Corey Johnson. I am a field engineer at Unity Technologies. This is Unity circa last fall. There I am, just in case you were doubting me. I'm going to take you through kind of like what Unity is, what we're about, and then kind of give you an overview of our editor, and just so that way you have some context when Jarek talks about his plugin later. I apologize if you already know Unity. We're just going to say high level, but I'm going to go really, really fast. And if you don't know Unity, I apologize because we're going to go really, really fast. But myself and my illustrious colleagues are in the sandbox on the 3rd floor in the Android section, so please feel free to follow up. So what is Unity? Well, we're a cross-platform engine. We come with an editor, which is a tool to create 2D and 3D content. We believe we have the best tooling in the industry. We believe that we give you a rapid learning curve and rapid iteration times. We have a mantra of build once, deploy anywhere, meaning we're, again, multi-platform. Our mission statement is to democratize game development. And that means that we want anybody out there who wants to build a game, whether an artist or an engineer, to be able to build a game. And that attitude has led to our tooling, and it also led to an enormous community, which I'm going to talk about in a second. When I say everywhere, I just kind of quickly define that. We're currently at like 13 different platforms and more are on the way. We even have Union, which is platforms that you may not even know you want to be on yet that we help get content to. So as you can see, we're fairly prolific, and if you want to be there, we're probably there for you. A little bit about our community. 1.8 million people use their product, 400,000 monthly actives every month, 5 million hours of creation every month. Enormous, from the hobbyists all the way up to AAA studios. One of the things we did to democratize this is build an asset store, which is a marketplace for our users to share content, whether it be tools that they built in our customizable editor that we just didn't get to, or if it's awesome artwork that people need. So like for me, I'm an engineer, I can't do art, but I can go in and buy awesome environments or a night to run around my game. One of the features that we use is called native plugins. We're going to talk a lot about it today, so I just want to kind of give you an overview of what they are. So Unity uses Mono for scripting, so that means you can run your game scripts across platform. But what plugins let you do is call native code to whatever platform you're on from your game scripts. For this talk, we're going to focus only on Android, and I will point out this is a pro feature. So first, there's 2 ways to do plugins. The first is the first is native and the second is Java. They're actually interchangeable. I'm going to talk about native first and then a little bit about Java. So here is an example of some code that's like C code that's a minimal plugin. All it does is return a value. All I need to do is put this C file and build it into a .so file using the Android NDK. And I need to place it in my projects plugins folder, which I'm going to show you in a minute. To call that code, and that code could be doing obviously a lot more complex things, all I need to do is from my game code, use interop services, annotate my plugin or my function definition, and then call my code. That simple. For Java plugins, it's a little bit different. We use the JNI to interact with your Java class that you build. You can build it a jar file using Eclipse in the Android development toolkit. Again, you just build a jar that contains all your classes, make sure you check the is library button, and then place that inside your plugins folder. We provide, because you have to do some work with the JNI to discover your methods and then invoke them, we provide some wrapper classes, the Android JNI and the Android JNI helper. And then on top of that, we built another layer of helpers, which is Android Java Object and Android Java Class, which allow you to not only automate the whole process, but we also cache those lookups so subsequent calls are a lot faster. So instead of showing you Java code for the plugins, I'm actually just going to show you an example here. And then Jarek's example is going to show a lot of Java code. So on this slide, the 2 lines that you see that are not commented out are what you need to do to invoke, to make a call to get this hash code string. All the commented outlines are what you would do if you had to do that natively. So it just kind of gives you an example of how much work we kind of save for you and how much prettier your code can look. That's about it with plugins. What you do with them is up to you. Here's some pro tips. When you're dealing with Android, and obviously you have the whole world of the native platform at your fingertips, you can do things like add activities and do things with stuff that we don't normally request permissions for. So in order to use that, you obviously need those in your Android manifest. Now, usually we generate one for you, but you can take that and modify it, add whatever you need, place that in your plugins folder, and just drop it right next to it, and we will automatically use that one instead of that way you don't have to rebuild it every time. One thing, whether it's for yourself, whether it's for future users, customers, whatever, teammates, you saw there was some work, annotating your function definitions, making the J and I calls. It's really easy to just drop in another code file that does all that work for you and just exposes the raw API as you want the users of this to actually, the plugin to actually see. We are dealing with native code and, managed code in your user game scripts. When you go down to the native level, obviously you're native, and we have to marshal that data, any data that you want to deal with back and forth. So be aware that there is some penalty costs to this, so you may have to weigh the benefits of where you want to do the work. We're talking a lot about video today for obvious reasons. I just want to point out some function calls that we're going to use later and what they do and explain them a little bit. The first is onRenderImage. This is a callback to you so you can basically react to whenever all the rendering is finished for your render target. This means that everything is done, and in this case, normally what we do is Michael Bay up the screen like here and add some bloom effects and lens flares. All we need to do it for to get a replay is to just copy the frame. Similarly, on audio filter read gives you a chance, every time we read a piece of audio data that we're going to send into the audio processor, you get a chance to customize. You can squelch it, make yourself sound like Darth Vader, whatever. Again, in this case, all we're doing is using that opportunity to copy that data so that way we can encode it later. When you're dealing with a plugin that deals with your frame time, you're going to want to be able to sync up your plugin work when you're going to get the frame versus when Unity's rendering, because you don't want to grab any frame data in the middle of when it's writing to the frame buffer. Wait for end of frame is an object you can yield to in your coroutines, and that will make sure that when you come back and that code executes, you're at the end of the current frame, and that just helps keep all the syncing together. Cool, I'm going to switch over to the editor now. Awesome. So this is the Unity editor. This is where you're going to build your game. The first thing I'm going to talk about is our project window right here in the middle. The project window is literally a mirror of what's actually on disk. It's all your models, meshes, textures, sound files, etc. You can literally go and look it on the file system, and it's going to look exactly the same. You'll see here I have this plugins directory. Plugins is one of our reserved words. We look for that folder and then treat things in there as plugins so we know how to build them into your final game. And then you just say, I want an Android. As you can see here, we have a custom Android manifest, and then we have a bunch of libs that Jarek's going to talk about later. So not everything in there is going to end up in your final build of your game. On the left here, we have a hierarchy window, which you can see here to the right of my screen. This represents everything that's represented in our drawn screen. So if I select my wall here, I can move it up and down and break his game and do all sorts of fun stuff. And here's where you build your layout of your game and all that stuff. So we are a component-based engine, which means that everything in our game engine is an object with components that add behavior. So over on the right, we have the inspector window. Whoa. All right, sorry about that. I will just proceed. The inspector window shows us all the components on there. So you can see that, I didn't do it. All right, 1 second. And we're back. Currently, I have the wall selected. We can see that as a mesh. It's a mesh render. It has some animation to it. It has a box collider, so things will, and all these do is tell the engine different things and have different widgets where we can customize how our engine reacts to these objects. If I select our main camera, we'll see that we have a bunch of scripts attached to it. Now, to get custom functionality into your game, you create scripts. Our scripts, again, are mono, so it can be C#, JavaScript, or Boo. We ship with mono develop, so you have everything you need to develop a game already installed. Inside here, we have, oops, it looks like I picked the audio one. That's fine. Inside here, we have the on audio filter read, and you can see all we're doing is checking to make sure that recording is active, and then passing that data to a convert and write function. Similarly, we have a similar function for video where we have on render image, where all we do is do a little bit of logging, and we are making a copy of the frame buffer. I mentioned earlier they have rapid iteration times. At any time, you can hit the play button located at the top of the screen there, and we go ahead and allow you to play your game and test it out. So I can test out the force of the tennis balls that we're shooting out, et cetera, et cetera. Awesome. So that's a little bit, so you have, when Jarek's in there later and showing screenshots, you kind of know what you're looking at. I'm going to pass it back to him now so he can talk about, maybe.
Here's the trick.
All right. Yeah, I'll do it.
Oh, yeah.
There you go.
All right. OK, thank you, Corey. So Corey took you through the process of creating a game with Unity. And if you're a Unity developer, then really the only thing that might be new for you is the way you integrate plugin capabilities. If you haven't tried Unity yet, I encourage you to try it out. It's a lot of fun. Now, what I will cover next is, OK, now how can we integrate video upload and video playback capability into the game to really take advantage of the opportunity out there that we highlighted earlier. First, let me switch back to my demo. And you know, the gameplay that I was showing you earlier when I scored an amazing amount of points, I actually ready to share it. I think it's really awesome. I'm just going to hit upload. And at this point, we're actually uploading the video to YouTube. I'm actually generating a notification to show the status of the upload. While that is taking place, let me walk you through what actually happens. So for this, we are using WebM as a video container, VP8 codec, and Vorbis codec for video and audio, respectively. Tomorrow morning, there's a talk about VP8. So if you would like to learn more, highly encourage you to check it out. And we're also launching VP9. There's another talk about the next generation of this technology. But let's just take a step-by-step look at what is involved here. So we start with this awesome Unity game. And then what we actually need to get out of the game engine is the audio and the video frames. So this is what is illustrated on this diagram. We're getting the video frames, passing them onto the VP8 encoder. We're getting the audio frames, passing to the Vorbis encoder, and then use the WebM container in order to create a video file for us. Once that file is created, we use the YouTube Data API. In this case, we use the YouTube Data API version 3 to upload the resulting video to YouTube. The YouTube Data API is RESTful. It's fairly straightforward to use. For Android, we use the Java client libraries. So you don't actually have to write any HTTP, HTML, HTTP JSON parsing code. Now, in our example, we built a Unity plugin in order to take care of the video upload from Unity and the video encoding. Couple of hints while developing the plugin. Corey mentioned the Android manifest is something that Unity generates by default, since it actually creates the APK. However, if you're building any additional activities in your code or need additional permissions, you need to merge that into the manifest created by Unity. So the way to do that is, first time you build a game in temp staging area, you'll get a Android manifest, and then you edit that and copy that over into the plugins directory, and you're all set. Another thing to pay attention to is that plugins are actually required to be built as Java Android libraries. So you actually need to be careful about resource merge. And really the only thing that is somewhat inconvenient is that if you're used to the ID-based lookup in your code directly, inside of the plugin while you're running in Unity, you should actually use the functional way of looking up, or the procedural way of looking up the resources. Other than that, it's just regular Android development. Now, Corey mentioned some of the methods involved in video and audio capture, so I'm just going to quickly go through what we did for this demo. So we actually attached a camera, two scripts to the camera, one script responsible for video capture, the other script responsible for audio capture. So let's start with the audio. We are actually capturing the audio at 24 kilohertz frequency. So this is the raw PCM data that you're going to be receiving in your application. You can actually configure that using audio settings, output sample rate. So this is something that you can configure in Unity. And then for video, I'm just using 10 frames per second right now. Unity has a nifty feature. You can actually set the replay frame rate, and this is different than the actual target frame rate at which your game runs, precisely for this use case. So if you want to record a video of the game, you can actually set the capture frame rate to whatever makes sense. And you do operate within the number of constraints that we'll touch upon a little later. So for audio recording, and Corey highlighted that when he pulled up mono-develop to show you the snippet of the code, we use audio filter read. So this is the callback that it's invoked by Unity at the frequency that you define using the mechanism from the previous slide. And what's passed to you is really raw PCM audio. And this is what we'll pass on to the encoder. Then for video, and this is again something that Corey highlighted, the continuation here, yield return new weight for end of frame, that allows you to be notified when frame rendering is fully completed, at which point you can actually turn around and read the complete frame back. And there's a number of approaches to this. We experimented with a few of them. They all have different trade-offs. Here's one. So this is the approach where I'm actually using texture 2D to read back pixels at a resolution defined by you. So you can actually generate a video at a lower resolution than the original. And this is, again, if you want the video file to be relatively small so you can be shared from mobile devices quickly, you can actually read the frames at smaller resolution. Another approach is to use the GL read pixels, so you can read it directly from the frame buffer using the OpenGL GL read pixels. And this is an example of another implementation that I did using Java. So that is actually invoked from within the Java plugin to obtain the frame buffer. So that's the capture step. Once the frames are captured, so the raw audio, raw video, we need to encode it. And for that, we're actually using WebM and VP8 plus Vorbis for audio. So let's talk a little bit about how that is done. And again, just referring back to our reference diagram, we actually at that stage right there in the middle where we obtain the raw frames, we are passing it on to the encoder. So one thing that is very useful on Android is our WebM engineers actually have created JNI bindings for the encoder, both the Vorbis encoder as well as the VP8 encoder. And you can fetch that from code.google.com. That is a JNI wrapper. It has dependencies on a few of the native libraries, but this is what actually provides you really nice performance. And this is what we used in our application. So a couple of things to consider when you're actually using this. So think of this as kind of nice, object-oriented way to do video encoding. So if you're not comfortable writing C code, but you're an Android developer, you know Java, well, now you can encode video. And you can do that very easily. So let's just walk through the kind of basic building blocks. Audio encoder, there's a couple of classes, the encoder configuration and the actual encoder. A video encoder, again, the configuration and the actual encoder. And then the WebM muxing capabilities so that you can write the compressed audio and video frames to a container and then end up with a single file. And here's an example how this looks in practice. So we start with a byte array, which is basically the PCM audio that was given to us by Unity as a part of the script attached to a camera. And then similarly for video, we read that video from the frame buffer. And then we construct ultimately, what we want is the audio frame and encoded packet, which basically represents the encoded audio and the encoded video. And the way that is obtained is we actually pass the raw audio bytes to the VORB-based encoder, pass the raw video bytes to the VPN encoder, and then we use the muxer to save the audio and the video frame. That takes care also of synchronization, so you don't really have to do any work in that area. And what you get back is a video file. So here's an overview again of the objects that we just discussed. So encoder configuration, both for video and audio, the actual encoders, the tracks representing the audio and the video part of the WebM file, and the muxer. So this is kind of the way I see it as an object-oriented way of doing video encoding. And I really like it because I think it's very approachable. So for those of you that would like to do a little bit more work in this area but have been intimidated by having to deal with a bunch of native code and a large libraries, this kind of provides an abstraction that is very easy to use. So once we have the video and audio, the only thing remaining is the actual upload. And the way we do that is using the YouTube Data APIs. I'm using the YouTube Data API version 3. So in order to access that, you need to register your project in the developer console. One thing to note is we are uploading the video into the user's account. Therefore, we must obtain an auth permission from the user for our application to act on his or her behalf. And the way that takes place, there's a little bit of magic involved. It actually works very nicely. The only thing you need to know about is that when you register your project in the developer console, you need to supply a fingerprint for the key that you're going to be signing the application with. And you have to tell Unity to use a specific key store, a specific key, to sign your APK. And once you do that, everything just works like magic. So we know on the server side, our API backend knows that, hey, this is your application that is generating these requests. So you don't actually have to change any code for this. And then the upload process, what I was showing you, a couple of hints. Don't block the user waiting for the upload. You can just do that as a service and then use a notification to indicate the progress. And then use resumable uploads, because if you lose connectivity, which is in fact very likely at Moscone Center right now, this should actually resume automatically. So here's one video that I created a little earlier. Let's just play it. So, and then let's check the I'm going to switch to the mobile device. So remember the notification that I was popping up as a part of the video upload right now indicates that, hey, my video has been successfully uploaded. Watch the video on YouTube. So when I click it, let me just select it. I can see the gameplay right in my game. And I'm going to tell you a little bit more about how that is implemented as well. But before that, just a quick note on authorization. I mentioned to you that we use auth2 in order to upload the video on behalf of the user. And to implement that in your Android application, you can use the Google Play services. So we're using Google Auth Util. Makes it very straightforward to implement the auth flow. And really the only thing you need is you need to remember about the scope that you're going to be requesting from the user. So in our case, I'm using YouTube read-only because I need that in order to check on the upload status. And I'm using YouTube upload, which is going to grant my application the right to upload videos. And that is reflected here by this pop-up that is generated by the auth for Google Play services. And then I was just showing you a while ago how the playback, in-application playback works. The reason why that is useful is earlier today you have learned about the new capabilities that we're launching in the gaming area. Personally, I think leaderboards and achievements are very cool, but I want a video to prove it. So this is one use case that you can implement is, if you have the upload capability, you could associate or keep track of these achievements and leaders and show, the most interesting footage from your users in the app itself. And for that, you can use the YouTube Android Player API. So this is an API that we launched a few months back, and as I was showing you earlier, it has the capability of high quality in-app video playback. There's very little work that is required in making that happen in your application. Really, all you need to do is drop in this library here, YouTube Android Player API. This is a small client library that actually relies on our YouTube app to do the actual video playback. So it's a very robust. It has all the capabilities that you see in the YouTube app, and you can make that available inside of your own app that is running inside of your Unity game using the plugin capability. A couple of things to note. The YouTube Android Player API requires a developer key that is slightly different than the dev key that we used for the all-auth uploads. And then we may prompt you to actually upgrade the YouTube app on the user's device. So if the app is out of date, because the user hasn't updated it or it's not set for automatic updates, we'll actually generate this error service version update required. Typically, that doesn't happen, but this is how we can make sure that the latest capabilities or bug fixes are actually made available to the user when they try to use our YouTube API to do video playback inside of your Unity game. And then our transcoding pipeline takes a little while, especially if it's high-quality video and we transcode it to a number of different formats. YouTube Data API v3 has this nice capability. You can actually check the processing progress in order to find out, is this video ready to be shown on all the platforms that YouTube support. So I highly encourage you to actually do that before you do, say, social sharing. So I was requesting G+ permission in my auth flow earlier, a few slides earlier. And the use case there is, once I'm done with the uploading, I want to share it with the world. But share it only once processing progress indicates that the video has been completely processed, because that means it will play on every single type of device that YouTube supports, all the transcodes have completed. So a few links. If you'd like to learn more about our APIs, go to youtube.com/dev. This is the link to the repository that hosts all the JNI wrappers for WebM, VP8, Vorbis, and libyov, which allows you to do RGB to YOV conversion, which is, again, a little detail that we didn't get into too much during this talk. And then we are working on polishing up this demo app, and then we're planning to open source it as well, so you can try it out yourself. So we hope that this capability will excite your users. Now it's 2013, so I figured someone playing a tablet game would be an appropriate way to conclude this presentation. And if you guys have any questions, please come up to the mic. We have a few minutes left.
So this will do a record as the user is playing the game, right? So what's the impact on the performance that you expect on the device? Because gaming already consumes significant horsepower on the platform, and then if you're going to record at the same time.
So the question is, what is the performance impact of this capability? Actually, the way this demo app is implemented, we are using a trick where the gameplay recording is not happening at the same time as the game. So I am actually doing a replay using the Unity capability where you can actually tell it to render frames at certain speed. So there is no impact while you're playing the game. However, when you're actually ready to share it, depending on the device and depending on how how you configured it. For example, if you want HD, if you want high quality video, because those are parameters you can pass to the encoder, then the actual rendering of the frames may or may not keep up with the frame rate that you get when you're playing the game. So there's an additional step that involves basically rendering the frames one by one. And at low resolution, low frame rate, right now, because I'm using a pretty expensive way to fetch the frames from the frame buffer, at low resolution, I can keep up with the frame rate of the game. At higher resolutions, I can't. However, that doesn't really important the gameplay, but it impacts the replay. Ideally, what we will want, and we have a couple of partners that do that for other platforms. In fact, there's one in the sandbox, and one of them spoke earlier today at the, you see raising his hand. So there's other approaches to that. They don't currently work on Android. So this is an alternative that can be used. Hopefully, we'll get to that same level of performance. But there isn't really, the impact right now is zero because the step of rendering the gameplay is distinct from the play.
So you also said VP8 and going forward it could be VP9. Again, does the developer kind of pick a codec there, whether it's going to be VP8, VP9, or is it YouTube that decides?
Yes. So the question is, what does it mean now that we have VP9, VP8? So the good news is you don't really care. So frankly, as long as you give us the content in any of the formats that we support for YouTube ingestion, we actually turn around and transcode it in everything imaginable that is required by all the devices that we support. So we chose VP8, and we're going to get into that into more details tomorrow, is because this is open source royalty-free codec. You don't have to pay anybody any money. You don't have to pay any royalties. You can do whatever you want with it, and it's it's a very liberal license and it's open source. So we find that this is a good fit for these types of applications. The way YouTube works is once you upload the video, we'll actually take care of transcoding into the formats that are supported by different devices. So if a target device for playback only supports H.264, we'll use that transcode. Then our Android Player API, which I demonstrated earlier for playback, uses one of these transcodes. So it really is totally transparent to the developer. The only thing you kind of have to know is, all these codecs have specific requirements. For example, VP8 requires an YOV representation of the data. That's why we have libyov also wrapped, so you can pass the RGB data that you get from the frame mapper, convert that to YOV, and pass that into VP8. So there's a little bit of knowledge that is required, but I would say it's pretty minimal.
So you answered part of my question with respect to, say, transcoding. Now, for recording, I assume it could also be H.264, or because most of the devices, they don't necessarily have support for VP8 HD record.
Yes, so we are using a software encoder right now. The way this application is built is the actual VP8 codec, Vorbis codec, WebM container is shipped as a native library wrapped through JNI and packaged in the Android plugin that is integrated with the Unity. So everything required to render the video is included in the game itself. Android has the capability to actually use the underlying hardware encoder, and that is typically H.264, though. And again, this is something that tomorrow's session is going to go into more detail. The world there is also becoming more attractive. But you don't actually need to. The nice thing about this approach is there is no dependency on a specific device or a specific version of Android, because it's just C code that you compile using NDK, and then the JNI wrappers. And it's also very small.
Thank you.
All right, so we have 20 more seconds left. If there are, there's one more question. Sure.
I wasn't from the beginning. I just want to ask, can we record the normal Java screen? I mean, the application screen. Written in Android without Unity.
Yeah. So the question is, can you record the application's screen? And I believe the answer is for an arbitrary app, the answer is no. And typically, it's because of sandboxing requirements and whatnot. So that's why this is something that has to be built into the application itself. And this is really how for PC games.
What are the mechanisms for building?
Yeah, so in this session, we actually describe how that can be done with Unity. And the mechanism for that is Unity has integration points to obtain the raw audio and the raw video frames. And this is what is actually passed into our encoder and uploaded to YouTube. But it's application specific. So Unity has this capability. It relies on the GL capability. So this is something that is app specific.
Okay.
And if this is not clear, I'll hang out after this. We can go in more detail. All right. So I think we're out of time. Thank you very much for coming, and please rate our session. Thank you.